other, you will notice that R, for example, produces the best graphics or the visuals than, for example, Stata or the eViews or all those other packages also.
Okay.
Okay. So we will do the programming part of it and some examples. Then from there, you can apply the basic knowledge now to do a big data analysis, of which we will do one. So. Okay. So I think we can now start as we wait for others to join. Cindy. Okay, so let's start. Have you loaded the commands that you are supposed to use today for today's class? Who has not downloaded the nini? Who has not downloaded? Benson, do you have the packages? Okay, I remember kuna mtu tuliambiana na yeye anitafuta after class so that I can assist him to install the R Studio. I think ako hapa ama bando? Is he around? I think if not, we can just continue. Let me share with you my screen. And if you have any question, please ask. Utilize your fees. Sit down. Yes. If you have any question, ask. So let me open my R Studio. So mwenye haja load the commands, you can do as I open mine. Let's learn this language together. Let's wait for the R Studio to respond to open. Okay, yesterday I remember I promised to give you some examples on the loop, the types examples, the real examples. Yesterday we did some programming part where we had the debug browsers, so we were not able to do those other things. So let's wait for my R Studio to open. The package is opening very slowly, I don't know why. Okay, who has any concern on what you scored in your SQL? Yes?
Kuna kitu umeniambia. One of the questions was like rename your column ya phone to phone number.
Yes.
Alafu after renaming, from there kwenda chini, if I wanted to return that column, I had to refer to it as phone number, not phone again, because I had named.
Oh yeah. I noticed that the nani there. So there were some people who are returning changing the phone instead of returning or renaming phone to phone number. They rename phone number to phone. Doing it so the phone number was starting. That is why some were experiencing some problems. So.
Oh, fine.
Okay. So I think you can open. Today we are on day 3, Cindy. Online day 3.
I have a question, Mr.
Yes.
Sam.
Yes.
You asked me a question about packages, yeah?
Yeah.
I was trying to remember which package specifically, or maybe I've installed, but I'm not very sure. Maybe something I missed along the way.
Okay. How many packages have we installed so far? I think it's only one. I told you to install the Rind Excel, and what I will say, Mr. Benson, when you install R, it comes with some installed packages. So it's upon you to add more packages. Now you want a package that you are going to use because you will download from the net. Do you understand? So we will install more packages as we progress with the course.
Yes, I understand. Now, which one are we supposed to download latest?
Yesterday the Rint XL.
Okay, thanks.
Yeah, the one for importing data sets. Now, yesterday I remember we were here on the loop, and we said loop, we end types of loop, we end for, we end while, the for loop, while, and repeat loop. Now today I've added some cones for this type of loops on day 3 before we start what we are supposed to cover today. Now when you open day 3, when you open day 3, we have a while loop. We have a while loop. I want you to check the syntax for the while loop. The syntax is very simple. You apply the while loop, then you give out the formula inside. You apply while loop, then condition, then you define the formula inside the braces. For example, I am saying while square is less than or equal to 300. While square is less than or equal to 300. I want to return a number n which is equals to n plus 1. Is n is just a number, then you do an increment. What is the formula for square? Is that n squared. This is the formula for finding square of numbers. So when you execute this type of command here, even before you get the output, we don't expect to get a square that is less than or equal to 300. Let's try to run this command here. Yes. Set this one or the second one? Oh, the second one here. We have to return a square here, not n. When you return square, we are getting square of number that is not less than or equal to 300. That is not greater or equal to 300. What is the square root of 441? What is the square root of 441? I want to hear from you. So what is the square root of 441? Is 21, is it? Yeah, it's 21. Now, I want you to understand this part here. What is the square root for 20? For 400, for example, a square root for 400 is 20. Sindio? A square root for 400 is 20. But now what we are doing here, we are doing a loop. But with a certain condition. We don't want this type of square to be less than 300. We want a number of square that will give us a number that is greater than 300. For example, when I insert here 400, let's say for example 500, 500, then we execute the command here. Let me check. What is the error? Non-numeric argument to binary operator. Oh yes. Let's check 400 for example. What is the square there? The square is 441. So this is how we can demonstrate a while loop. But now you can define some values that you are going to use inside here. For example, here this is a different code, but using this the same syntax. So if you don't understand the syntax here, I think here you will understand more before we jump on what we are supposed to talk about today. When you define letter I to be equal to 1, when you define letter I to be equal to 1 and letter n to be equal to 5, while I is less than or equal to n, I want to print values of I. Values of I. That is, I start from I, which is 1 here, then we do an increment up to the increment of 1 until we reach this point. Then we break out. Let's see. Let's see. That is, I is equals to 1, n is equals to 5. Remember, this is the same as equal to, so as we said yesterday. This is the same as equal to. I can print values of I where I should be less than or equal to n. So my I should be less than or equal to 5. So then I can print the values of I. What do you think will be the output here before we execute the command? I want to hear from you. We want to print values of I. Remember, I should be less than or equal to n, where n is equal to 5. So then we print I where I is an increment from 1 to 5. So I expect to get numbers from 1 to 5. So from 1 to 5. That is it. I inserted another type of for loop here. We can have a vector count animals, which has animal names. We have the koala, cat, dog, panda, or any other type. Then I can say, this is a for loop example. I can say animal in animals. Check here the difference here. I want animal, so I have defined a certain variable here called animal that should be inside this vector called animals. So animals. So what am I returning? I am returning if the number of characters n char, this is a command or a function in R. Number of characters in animal should be less than 4 number of characters. If you check here, we have 3 characters. Here we have 1, 2, 3, 4, 5. Here we have 1, 2, 3, 4, 5. So then this process will break if these values are less than 4, and I can print my animal. Let's see. Okay. Some of you or one may ask, why are we getting only koala instead of panda? And the panda has the number of characters are less than 4. The number of characters are less than 4. Who can tell us the reason?
I think it's because you said.
Yes.
I think it's because you said you break after if anything, it's lesser before you break. But after cut is 3 already, so that's why it has broken. Can't go on.
Yes, yes, very good. That's the reason.
But may I
So
share my screen because I'm not getting the same thing?
yes, yes, yes. Actually, check here. What happens if we insert 5? If we insert here 3, what do you think will happen even before you execute the command? What do you think will happen? The number of characters should be less than 3. So we are returning number of characters, number of not number. We are returning animals, which has the number of characters in animals is less than 3. Then we can break the process again. That's why you will notice here we have 3 letters. Here we have 3 letters. So here we have more than 3. That's why you will get this one here. So yes, that is it. So you can do more research on this type of loops even in YouTube's. We have a lot of things there. We have nested while loop. Nested while loop is when you return a loop of while inside another loop. So for example, if you check on this code here, you'll notice that we have I which is equal to 1, for example. So I is equal to 1. While this I is less than or equal to 4, then I define another variable called j which is equals to 1. After that, I introduce a while loop inside this while loop. While j is less than 2, what am I going to return? I'm going to return I plus j, where j should be 1 plus 1, or the increment, and I is I plus 1. We do increment until 4 and here until 2. When we execute this type of and here you will note that we have 2, 3, 4 and 5. 2, 3, 4 and 5. Why are we getting that? Guys? These are the values of I and j. The values of I and j. Remember, j is 2. J starts from 2. So and we do an increment of 1. It becomes 3. It becomes what? 3. So we have 2 and 3 for j. We have them here. And for I, which should be less than or equal to 4, my I should start with 4. Then we do an increment of 1 here. That's why we are getting 4 and 5. 4 and 5. So the j part, the I part, the way they are following each other here. Print I plus j. So I plus j. That is it. So the value of I is 1, the value of j is 1. What do we do when we do that addition? That addition should be 2. Then we do an increment of 1 on j until j is less than 2. So that's why this process is breaking at this particular point. So then from that point you can do addition. Let me check. You can do addition of vectors.
Sir,
Yes.
before you go on,
Yes.
I'm lagging behind a little bit. I just wanted to ask what are the packages that we're supposed to install?
Okay.
Because I can't do anything until I download those packages.
Okay. Have you installed the RStudio?
Yes.
We will be installing packages as we progress with the work. So.
Oh, yes.
Yes. Now,
Uh-huh.
you don't have to have any package until now.
Okay.
When you install the package, the software comes with some basic packages. So.
Yeah.
So those are the packages that we are using. When we will start installing them, we will be installing one at a time. Then we use it.
Okay.
Yes.
Thank you so.
But you can open the commands. Sindio?
Yes, I can open the commands.
Then you can just execute them. The commands from the tree. So. Do you know how to run a command in this platform?
Yes.
Okay.
Yes.
Very good. Very good. Let's continue now.
Thank you so much.
You're welcome. When you store some data in vector form, for example, we have a vector called x, where our vector. Remember, these are the same as the equal signs, so it should not be. They should not bother you so much. These are the same as equal signs. Also, when we store data in vector of a vector called x, for example, which is equal to c. Remember, c is a function used to store data in vector form in R programming language. When we execute this command here, we have them stored here. We have the execution here, then we have that particular variable being stored here. Then we can have the y. Yes, we have
I have a
y here.
question.
Pardon?
I have a question. If I may share my screen, because every time I just get an error, like if I'm getting an error, anything is not found, object I is not found, and so on and so forth.
Okay, can you share your screen with us? Is it possible?
Yes.
Yeah, okay, share with us. So if you encounter any problem, please don't keep quiet. Ask. So we are here for you. So we are waiting for Benson to share the screen. So object I not found. Sindio?
Yes. I've been getting those kind of errors. Yes.
Okay. Can you do?
I had a similar problem.
Uh-huh.
But again, it is the statements in R because we have to execute them one by one, supposed to executing at the end. That's what I have observed on my side.
Okay, Mr. Benson, while your cursor is at that point, I want you to click run. What is happening? Yes, I can see.
It is working.
I can see the compiler is executing the commands. Sawa. Yes, click there, run. Yes. I want you, before you click run there, I want you to click enter, then you type X. Just a new line. Yes. Kwa hiyo line, write X, then run the command. Okay. Do you see what you are getting on the output?
I think I'm good.
Okay. You are good to go. Yes, you can share your screen now. Mr. David, is it possible you share with us your screen?
For me, I'm okay. I was just pointing out that's the same experience I had, but I noticed it's because we have to execute statements one by one.
Yes,
but
you have to. Yeah, very good. So you have to execute statements one by one. So So we can continue. Sindio? We can continue. This is n. N is equal to length of x. N is equal to length of x. Let's see. N, when I say n is equals to length x. When I say length, n is equals to length x. What is the length of x? X, I can say we have 1, 2, 3, 4 entries. When I execute that command, I call n, I expect to have 4. N to be of length 4. Why? Because of this length, we have 4 inputs. Then I can assign I to be 0, then z numeric n. Let's see. Execute each command, each line. So what is z? Z, when we use a numeric function, it will just return the empty entries. So that's why we have E as 0, 0, 0, 0. But I'm sure we have 4 entries somewhere, but we don't have those particular data. So now we can apply the while loop. I can say I is less than or equal to n. What am I returning? I'm returning z times I, which is equals to x times I plus y times I, where I is an increment from this part here. Let me adjust this. I should be less than, I is 0, which should be less than or equal to length of 4 of x. Remember, n is 4. So what do we have as z? Is this the empty storage of 4 entries of x. Now you can multiply the empty entries of z with these values of I. The zeros there. So then what do you get? When we return z, we get 1, 2, 8, and 5. Who can tell us the reason why we are getting those values? Who can tell us? Just to do this, remember the values of z is 0, 0, 0, 0. You can multiply by I. The value of I is 0. There we get 0. So this is just an equation. The equation that we always solve for example, A. For example, 1a plus 1b is equals to 5, then with a certain constant. The constant of z now is the one that is solved here, and which should return that particular number here. So if you do it manually, you will get the same. So we have the repeat loop. How do you do the statement on repeat loop? How do we do a statement on the repeat loop? On repeat loop, the syntax is simple. Remember, this is part of R programming, not the data analysis. So we insert the repeat, then we insert the condition if, then we stop that particular condition, then we stop that particular condition. I think we have an example here. let's do it before we dive on what we are supposed to cover. For example, here you can say x is equals to 1, then we repeat the loop, print values of x, then this statement break or terminate if the value of x is greater than 4. This, the part here was 4, so then we can break that statement. For example, we execute this part here, we have 1 for our first case, then we can break if the values of x is greater than 4. This is increment of x by 1, so my statement ends there. My statement ends there. So we break the statement to terminate if x is greater than 4. So the number which is greater than 4 is 5. So we end our process there. If we used less than 4, what do you think? We would have 3. We would have 3. So that one is simple.
Excuse me, sir.
Yes.
So if the increment x by 1, if it was by 2, would have stopped at 6.
Let's see. If we did an increment by 2, what do you think will happen? What happens? Increment in R is mostly done using 1. We are trying to increase, or to, what can we say, to expand that particular number. So we are trying to expand that particular number. That's the reason why you will not get the values from 1 to 4. From 1 to 4. Remember, your condition from breaking is this number should be greater than 4. And your x was starting at what? Your x was starting at 1. Your x was starting at 1. Now, if you increment by 2, what you will lack is just the first values until your statement breaks, because R will only display values that have been incremented by 1 for pattern purposes. So that's why you're not getting 6 here, but you are getting the exact number where our process is ending. Okay, so you can do this one here. This is x is equals to 1, sum 0, repeat. So sum is equals to sum plus x, sum which is 0 plus 1. Then you can print sum direct. Then you can print sum where x is an increment. Now, today we are supposed to cover these things here, and I'm sure we will do them. This is 1, 2, 3, 4, 5, 6. This is erase data set. No, this is an inbuilt data set in R. So we will not do this. We will start on vectors. The vectors that I've been talking about. Now, what is a vector in R? These are the most basic of R. Data object that data object, and there are 6 types of atomic vectors. So remember, the first vector that we did is just a simple vector for storing data sets, for storing data values. When we print, I want you to begin here. When we print character values, we will be using these quotations. So these quotations triggers or direct or tells the compiler that we are printing character data type. Then we have the atomic vectors of type double, which is a decimal. So then we have the for integers. Remember, for vectors and integers, they are not enclosed by these signs. And we can print the logical vectors. We have the true and we have the false vectors. For example, when I print ABC, you will note that what I have here is just ABC. When I print this one, I will just have those values there. So these are the types of what? The types of vectors. Yesterday, I remember we handled a complex number which is formed of by a real part and the imaginary part of I. This is an atomic vector. We can have the atomic vector of type rho. This is the hello world. The hello world, for example. This let's execute this one here. Yes, that's the I. Then we can print characters to row. I want you to go and research on what is arrow vector. Arrow vector. Then you will understand what these values here means. Then you can have multiple elements. For example, V is numbers from 5 to 13. Then I can print the values of V. Let's see. I can print V here from 5 to 13. Then you can print a sequence, for example, from 6.6 to 6.6 to 12.6. 6.6 to 12.6. So the compiler will do what? Will check the difference between the pattern that you want to execute or the sequence that you want to display based on your point. For example, here is 6.6. I expect to go up to 12.6, so I will do, the compiler will do an increment of 1. So you can execute this. Yes, let's start here. So you can execute the ones that I haven't executed. Let's use the C function, the function that I've been talking from yesterday, of storing data. So the non-character values are coerced to complex number, to complex type, if one of the element is a character. This command here, the logical and numerical values are converted to characters. Why? Using the C function, the non-character values, they will be coerced to character type if one of the element is a character. That is a direct translation as far as this command is concerned. So when we print S, yes?
I'm sorry, I had some problem with connection, but please move your cursor back to the code in line 144.
Line 144.
Yeah.
Okay. This is line what? Yenye tumeacha line 176. 144. This one here.
Yeah. What does that code do?
Okay. I've told you to do a research on what is a vector of type row. So
Fine.
ama hujasikia or I can just tell you, sidio?
Like nilikuwa na shida ya connection.
Oh, sawa. So niwaambie ama mfanye research?
Tuambie, tutafanya research pia.
Hapana, nilikuwa campus, hata mimi nilikuwa nataka you can do some research, but actually this type of vector we don't use it so much. So this type of vector here is used just to present a row sequence of bytes. That's why when you execute this command here, these are very small numbers. For example, what is 68? What do we understand by the name byte? They are just they will just create a row or a vector of specified length. So each element of vector should be equal to 0, or it will just return random values of a sequence. So yes, that is it. So I think we can continue. And of any more research on it, but we don't use it so much. So are we together now?
Yes.
Yes. So this one here was for returning what? Changing data type from vector, from integer and logical operator to character value. So then you can access the vector elements. I want you to check here, for example, what do we have here? When we return some vectors, when you return a vector, you will get this kind of bracket here. This kind of bracket is telling you that that particular vector has one row for as far as this bracket is concerned. When you have let's say 100 entries, you can apply these commands, this type of bracket, to return until a specific value. For example, you can return until all values up to 70. So you return bracket this and 70. That is how we assess what? Vectors, element in a vector. For example, when we say t is equals to Sunday, Monday, or this up to Saturday, u is equals to t, then we can use this kind of bracket here to store 2, 3, and 6. Then you can print the values of u, for example. What will happen? It means my value of u are picked directly from the vector t, because we have t here, but we have picked the second, third, and sixth value from this vector. So the second value is Monday. That's why we have Monday here. Third value is Tuesday. We have it here. And the sixth one is Friday. We have it here. So that's how we print. We access vector elements. Then you can access vectors using logical indexing. The logical indexing, remember the logical operators. Let's have v, which is equal to these values here. I want you to begin here. The values of v is values of t. You can see we have t here. Then we specify specifically the number of the positions of values in t. We say that Sunday is a true value, Monday is a false value, Tuesday is false value, Wednesday is true, Thursday false, Friday true, Saturday false. So when you execute this command here, you have assigned v to those particular entries. So when we print values of v, what do we have? V will return only values that are true from t. V will return values from t that are true. Which values are true here? We have the first one is true, is Sunday. This is false, this is false, the fourth one is true. The third one, which is Wednesday. The other one that is true is the sixth one, which is Friday. That's why we are getting these particular values here. So okay, let's try now to manipulate vectors. Let's try to manipulate vectors. We have vector 1, which has these values here, and vector 2, which has these values here. The result is equals to v1 plus v2 print add dot result. So print add dot result. Remember, the result is a function of v1 plus v2. When you execute this command here, you have saved it. You have saved v1, execute the other one, you have saved v2, execute the other one, you have executed this part here, then you can print. What happens when you print a vector? When you print a vector, these values are added indirect. So that is addition of vectors. For example, 3 plus 4 is equals to 7. 8 plus 11 is equals to 19. 4 plus 0, blah blah blah, up to this point. You can subtract these vectors. You subtract v1 minus v2, so I'm expecting 3 minus 4, which is minus 1. Cinder? Yes. And you continue like that. You can multiply them. Remember, the sign for multiplication is the star, and you can execute this command here, for example, and you note that 4 times 3 is 12. So when you confirm one number, you are good to go. Division, use this sign for dividing vector 1 divided by vector 2. So vector 1 divided by vector 2, then you can divide them and get the answers. So this is the first one, is this, the second one, third one, blah blah blah, up to going down. So yes, that is it. Let's now sort the elements of vectors. Sorting elements of vectors. V is equals to these values, for example. Then I can sort the result of V. So sort this is a function, sort V. When we execute this command here and store that particular data there, then we can sort this particular data there, then we print the sorted value, where we start from the most negative to the most positive number. Remember, the first one is 3, blah blah, we have 0, we have negative 9, so we start with negative 9, 3. That is how we sort numbers. Sorting element in reverse order. We have our V here, and we sort V. Decreasing is equals to true. These are logical operator here. That decreasing is a function. That's why when you try to type decreasing here, for example, let's just try to type decreasing. Decreasing, which is equals to true. You can see what is happening here. The true value, the true part becomes below, because these are logical operator. But now decreasing is a function. That's this language understands decreasing the way you understand it. So that's why it's a function inside this particular language, as far as this command is concerned. So we can return from then decreasing order, then we print the result. So we start from 3 or 4 going downwards up to the most negative number. We can sort character by vectors. For example, when we have a vector which has string values, we can sort these values here. Okay, before I sort them, which criteria will the compiler use to sort these values? Which criteria will it use? I remember yesterday when I was talking of letters. Which letters are used to perform sort operation as far as this command is concerned? I want to hear from you. Guys, I want to hear from you.
Alphabetical, from A to Z.
Yes?
Sort of alphabetical from A to Z. I'm thinking that way.
Okay. Very good. It will use the alphabetical order. So. And it will use just the first words. The first letter of a string. The first letter of a word. So. The first letter of a word. This is R, this is B, this is Y, this is V. For example, B will be assigned number 2 in alphabetical order. So I can sort. So I'm expecting the B to start. Until you go up to the Z value. Then you can sort this part in decreasing order. Yes, you can also do so. Let's jump on our second subtopic, that is matrices. Syntax for matrix is very simple. When I want matrix Z, for example, I will say Z is equals to matrix, where matrix is a function. Then I give the rows, the values that are forming that particular matrix, comma, number of rows, comma, number of columns. Then you are good to go. So. Yes. For example, the syntax for creating a matrix is matrix, then you insert the data, number of rows, number of columns, by row, then dimension name. Then you can even insert the dimension names. So one question, okay, let's continue before I give you that particular question. What will this function here do? It will take values from 3 to 14, for example, where m is equals to, let's follow this syntax here. M is equals to matrix, yes. Which data am I using? I have my C function here to store data from 3 to 14. So this part here will form my data. Number of rows, we have number of rows which is equals to 4, then comma, number of columns, then we have number of columns 4. Then by row means, it means my matrix, more emphasis will be put on number of rows, so that even if you have a number that are greater than 3 to 14, you will just get an error if your rows, if this number does not correspond to your number of rows. For example, when I execute this command here, then I print my m, I expect to get a matrix of number of rows 4. We have rows, row 1, row 2, row 3, row 4. Now, how do you access the matrix values? For example, I want to get the matrix how do you return row 1? only row 1, we will learn the syntax as we proceed with our course. Elements are arranged sequentially by columns. In row, this should be n call. Oh no, n row. Why not n call? Because by row is equals to false, not true. So we are not basing our argument of matrix n more on the row. So if it is not on row, we put more emphasis on columns. So we put more emphasis on column. That is it. So this is the matrix. You can define the columns and row names. Yes. Remember the syntax here. You can have by row either true or false. Then dimension names. We can have dimension names. Instead of having 1, 2, 3, 1, 2, 3, 4, we can rename this what? These entries. How do we rename them? The syntax is very simple. Our P is made of matrix of numbers from 3 to 14. Number of rows are 4. Yes. Then by row is equals to true, so our emphasis is put on number of rows. Then dim name. Then dimension names is a list of row names and row and column names. Row names and column names. When you execute this command here, what happens? Let's see. Let's see why I'm getting an error. Why is there error in matrix? Let me check. Invariance type closure for dimension must be a vector. It must be a vector. So let me check. Another thing, as you learn this, as you learn this language, let's return them here. So we are supposed to have these names somewhere. Let's have them here.
Yangu imefanya tu vile ulikuwa umeiandika.
Pardon?
Yangu imefanya tu vile ulikuwa umeiandika.
Imefanya? Kwa nini ifanye hapa kwa mashine yangu? Nani mwingine imefanya kwa mashine yake?
Mine as well.
Okay, so my machine inaweza kuwa na ujinga, si ndio? I think we can just continue from this part here. Yes. Let me delete this one here. Tuone kama it will work out. Ukikataa tu tunaendelea. Achana nayo. Sawa. Achana nayo. We can yes.
Janam, your dimension.
Pardon?
dimension name, column name na row name hujarun.
Which one here?
Row name na column name hujarun.
Oh, yeah. Nimepata mistake, huh? So nimepata mistake yenye nimefanya. Sikuwa nimerun this command, sio? Sikuwa execute this commands. So we can run them. Those are the number of columns. Then we can execute them. Yes, it has changed those parts. Now, how do you access a specific element of a matrix? How do you access elements of a matrix? For example, let's run this command here, and the other one. Then we can create a matrix. Then you can create a matrix there and return P. Now, I want you to be very keen here. When we want to let's check the matrix P, printing P into this closed bracket 1 and 3. It means we are returning the value that is exactly on row 1 and column 3, which is 5. See there, which is 5. Let's see the, yes, you can see what we have is 5. And what happens when you want to return only row? You can delete the 3 there and run the command. So then you can return the whole row. So but what do you do when you want to return a column? You start with the comma. Comma, for example, 3, comma 3. It means I want to return only the third column. We start with the compiler is rows by column. Now we want to return the third column. When you execute this command here, these are the values of the third row. So then you can access the values on the second column and fourth row from the matrix, which is 4. You can check if it's really the one. Yes, 4 and 2. Row 4 and 2 is 13. So that's how we execute what? That's how we return specific values. Then we can do matrix computations. We can have matrix 1, for example, which is equals to a matrix which is formed by this number and number of rows are 2, for example. And another thing, if you insert values that are greater than the multiple of number of rows that you want to return, you will get an error. So for example, when I execute this command here, that's my matrix. I have 2 number of rows, and when I execute the command, yes, those are the values. But now what happens when I add another value there? Insert command and another value, then try to execute the same in your machines, you get an error. So in matrices, the number of rows must be a submultiple of the number of rows that you want to return. So yes, so you can delete one entry there and remain with your matrix, then you can form the matrix 2. We can return matrix 2 and print our matrix. We have the matrix there. We can add these matrices. We can add these matrices. Matrix 1 plus matrix 2. We add this the matrix 1 and matrix 2. Then we print that matrix. What happened? I can execute that command of not confirmable Harris. Why? Let me see. This one here, I want you to get the reason why we are getting this type of errors here. So you will notice that here we have a matrix of 3 by 2. No, these are 2 by 3. These are 2 by 3 matrix, but matrix 1. But matrix 1, that's a 2 by 3 matrix, but the other matrix is a 2 by what? A 2 by 4. 2 by 4 matrix. So these matrices are not confirmable. So these matrices are not confirmable. What do? We can reduce number of matrix 1. We reduce 2 numbers so that we can have a 2 by 3 matrix. So then from there we can do this. Yes, let's try it. This one here, that's a matrix 1. Argument. Oh yes, this the comma that I left it there. I think it will execute now. Yes, we have that one. Yes, now we can do those other things. I can add the matrix, cast. So result of addition is print what? The result. So you can add those 2 matrices. What do we add? The row 1, the column, the row 1 column 1 value in matrix 1 plus row 1 column 1 value in matrix number 2. That is it. Then you can do subtractions. I want you to begin on the signs that we are applying here, and so that is addition. We have subtraction here. You can run the commands and see the subtraction. So the result of subtraction are these ones here. Then you can multiply those matrices. We have matrix 1 here. We have formed another matrix here. We are on multiplication and division. So that's my matrix 1 now. This is my matrix 2. So that's my matrix 2. Multiplication of matrices, you just use this multiplication sign here, the star, then you execute that particular command, then you can cast. Or cut is used to display an expression directly to the output window here. So when I say cut result of multiplication, then I comma this blah n. It means I want to display this result of multiplication here. Then this one here, will be used to display the output of what you are doing on the next line. So that is how this part works. That's how that part works. Then I can run the command, then we can have this part there. From there you can do division. You can do division in the same. Use this sign here to do division. You can run the commands here, cast out the division, so then you can print out the division of that particular matrix. Yes. Well, we are on halfway. We have something that we call a list. Anyone with the question up to that point before we continue? Do you have any question up to that point before we continue? Claire, I want to hear from you. Do you have any question? Are you following us? Are we together?
On the division side, yeah.
Yes.
Look at the result in column 2.
The result
First,
on
first row.
the result on column 2. Yes.
First row. What is negative?
Negative infinite. I want you.
Of such.
I want, as we have matrix 1 here, that is the value of matrix 1. So. And the other part here is the matrix of part 2. What is negative 0, negative 1? A number divided by 0 is a number divided by 0. 1 divided by 0. That is definitely infinite, isn't it? But now we have a negative number that we want to divide by 0. We will have a very, very huge number because we don't understand the value of 0. We don't understand the value of 0. That's why we have a negative infinity. Negative infinity. So.
Thanks.
Okay. So we can do something that we call list. List in R are objects which contains elements of different types, like the numbers, strings, vectors, and other lists inside it. So a list can also contain a matrix or a function as its element. List is created using the list function. These are some of functions. These are functions that we will be dealing with. We have so many functions in this language. For example, when I say list data is equals to list, I am applying this function here. So anything that I will write inside here will be returned to list data. So I have red, green, then I have some data I've stored inside here using the C. Then I have the logical operator true. Then I have then decimal numbers here. So when I execute this command here, what we have is a list. What we have is a list. Then I can print the list and see what do we have. We have this kind of list here. List 1. List 1 is range. We have it here. So that is on list 1, row 1, column 1 in this vector form. So we have the range. We have the second one, the second value. That is why we are getting this 2 here and 1. It means the second entry in that line, in that row 1, is in green. So the that value is stored as a collection of numbers, but there are 21, that 2011. The fourth value is a true value, and the fifth value is 51. The sixth value in that row 1 is this part here. That's how we do listing. That's how we do listing. From there you can name list elements. You can name list elements. For example, the list element can be given names. and they can be accessed using what? Using the names. So for example, list data, when we list January, February, this plus this, we have another matrix there, we have a number of rows, blah blah blah, list green, these things here. We can return the values using the names. So let's see. Names. Now what we want to do here is assigning list data now, because we have the list data here. You can access it from this part here, list blah data. So you can access it there. You can see we have them here. But now I want to name list data. So I want to name the list. For example, this is list 1, list 2, list 3. So the first list is the first name of the list is, this is the first quarter. For example, this part is a matrix, and the other part is just an inner list. So you can create a list inside a list. So that's why we have list here and we have list here. So you can apply that function inside another function. So then from that point we can print the list. Let's see. Yes, we have the list here. For example, for the first one we have the first quarter. Instead of having 2 then 1, we have the first quarter. The second one is a matrix. This is the part of matrix here. We have it there. So that's how we do those. That's how we name matrices. That's how we name list. I'm sorry. That's how we rename list. Now, how do we access list elements? How do we access list elements? Remember, the syntax is the same. We use the closed brackets. We use the closed brackets. So you can have this one here. Then we can name it there. From there, you can print list number 1. You can print list number 3. For example, I'm expecting list number 1 to be the first quarter. So yes, the first quarter has these entries. That's just a normal list. That is a normal list. So the third quarter is the one with the inner list. So the one with the inner list. Then we can print this data as I think this command was not supposed to be here. I'm sure. Yes. So from there you can do manipulation of list elements. You can create a list containing a vector and a matrix and a list. So for example, this one here, you can see we have the first quarter here, the matrix, number of rows, then we have it inside there. Now let's see. You can name that matrix now, that list I mean. From there you can add an element at the end of the list. For example, here we have first quarter, a matrix, and inner list. Then you can add another list. See there? You can add another list here. That is the new element, for example, and print that final what? That final element. So the final element is new element. Remember, it is empty. It is empty because we have just added it here. So you can remove the last element. List data 4 is equals to none. For example, not applicable. So then print and data column on column 4 is null. So is null. Then you can update list data 3. You can do updated list, not updated actually. You can update list on that element of the list, the values on that part. So then you can print that is the inner list is the updated element. Then you can merge element, for example the list. We can merge list. You can have list 1 here, for example. So those are the values of list 1. You can have list 2. So you can have list 2, and those are the values of list 2. And then you can merge both the list 1 and list 2. So merge list is equals to you store list 1 and list 2. Check. I want you to check the values on list 1. This list here, it has some values, and this is the other list. Then you can merge those lists. So the first one goes to the first one, forms the first entry of a list of the new list. So yes. So what do we have here? We have the merged list 2, 3. Let me check. 1, 2, 3. Then from there we start with the Sunday, Monday, and Tuesday. That's how we merge lists. I want you to be thinking of type of data in your area of specialization that you can merge, so that you understand how you can apply this particular knowledge. So you can convert a list to a vector. For example, list 1 is equals to list of numbers from 1 to 5. Then I can print those lists. See that list 1, and I see values from 1 to 5. Then I have list 2 from 10 to 14. I can have those values from 10 to 14. Then when you want to convert list value to vector, you use unlist. You use unlist functions also. So for example, v1 is unlist list 1. So I am expecting to get v1 as a vector of values on list 1. So yes, that is it. I can print the v1 and see what we have is just a normal vector. What we have is just a normal vector. Okay. What else can we have? We can add the vectors. For example, we can add these two vectors now that we have unlisted from list 1 and list 2, and print those particular entries. We have another thing that we call character vectors. A character vector is just an atomic vector whose type is character. What do you understand by an atomic vector? Before we continue, I want one of you to tell us. What is an atomic vector? I want to hear from you. Nyaga, what is an atomic vector? What is an atomic vector? So atomic vector is probably it's just a fundamental data structure in our programming language. So an atomic vector is different from the one-dimensional arrays that we use in data science field. So yes, that is it. So a character vector can have string or not applicable as values. For example, when I have this type of vector here, vector x, which has values from a, e, I, o, u, so then I can print the type of x, the type of x. When I execute this command here, I have saved my data. Then from there, printing type of x, print type of x. Type of is a function in R programming that is used to return the data type that is forming a certain or a specific vector. So I can print those particular the type of x, which is formed by character. Then I can print the values of x, for example. Then I just return them. Then I just return them. We have this type here. We have the character and logical values. The null. Let's run and see the type of x here. This type of x has character. Remember, character can contain values, for example, together with this point. These are all characters. You can see we don't have the integers here. We don't have any number that is formed by integers. Yes. Then the second last part is the subsetting of subsetting will allow user to access element from an object. For example, it takes out a position from the object based on the condition provided. So there are 4 ways of subsetting in R programming language. Method 1 is subsetting using this operator. Is subsetting using this operator. For example, when we have assigned x values from 1 to 15, for example, check. You can print values, so they are values from 1 to 15. The original vector of x cast or print vector. I want my original vector of x to display on the following line. The line just after original vector pops out. So the original vector is this one, these values. The original vector of x. The original vector of x. If we end any other thing to display, it will be displayed on the next part. You can subset this vector, for example, the first 5 vectors x 5. This is the part of subsetting from 1 to 5, for example. Check. From 1 to 5 we have 1, 2, 3, 4, 5. But now what happens when I want to return values from 6 to 10? From 6 to 10, what happens? I will just pick values from 6 to 10. That is subsetting vector. Now what happens when I return x? I want to return, then I use this minus here. Minus c means I want to display values of x apart from the ones that are in this list. So apart from the ones in that particular list. So I remove the first, second, then the 50 from the list, then and display these others here. So you understand how the power of minus c, the power of minus in this part. So the power of minus. Another thing, you can subset using the double closed brackets. Let's see, for example, we want to create a list of A1, B2, C10 and D20. So this is just a list. Yes, I want to display the original list of S. So the original list of S is this values here. But now I can pick the second from the list. See the first element of list, for example, check here. I want to understand how we read the cones so that we may understand, you may understand how to implement it and so I think this should be 1 as far as this part is concerned. Then you execute. So the first element of list is 1. If you want the third element, what is the third element? So the third element is 10, but remember to change this part. So this should be that. That one should be banned. So creating a list, you can create another list here. For example, I want you to go and revise this course at your own time, because we have so many things to do in this language, and we don't have time. We can create a list. That is Z is a list of A, which is a list inside a list of X1, Y, this one. The part of B is equals to 1 to 10. For example, we execute this command here, then we print the values of the original list. The values of the original list, we have them here. So the first one is 1. The second one is this part here. The third part is these values. These values. Then we can print the CFG, this part here. Remember the position where it is. It is on the first row but in second entry. First row but in second entry. So we can use those double closed bracket to demonstrate that one. Or you can choose to display the third one. Subscript out of bound. Why? Let's see. Returning the first one. Right here. Let's try to return the first one and see. The first one is 1. The second one. Okay, yes. So it won't return the third one because this is we expect to return a specific entry of a list, but not values that have been defined inside another entry, like B that you can see. But for this one, we can return it because it's under list, because it is under list. So subsetting using let's jump on this one. You can subset using this part here. So operator can be used for list and data frames in R. Unlike this part here, the part that we are using, the closed operator, the closed bracket operator, it will just select only a single observation at a time. So it can be used to access an element in named list or a column in data frame. For example, you remember in SQL when we were trying to display a column of a certain table, we used, for example, table store. We were typing store dot phone or store dot customers. So, but here now we can use store $ customers. So this function, you would use it a lot. You would use it a lot in data analytics. So let's see. For example, when we have this kind of data here, this is the part of the list. We have list A, B, C, and D. You can return list A from is. So what are we casting out using this operator? We want to return the value of A, from the is list. So the value of A from the is list is 1. So you can see we are returning the 1. And you will note that even before, when you just write this $ here, the subset of that particular list will pop out. For example, if I want B, and just return it direct. So yes, that is how we do it. For example, we have data set, inbuilt data set called cars. What happens when you execute this command? I want to hear from you. What are you getting? Hapa sasa ndio challenge iko. I want us to do something else here. What is empty cars? You will notice that empty cars is an inbuilt dataset that comes with our programming language. So when you install the RStudio will come with some inbuilt datasets. One of them being empty cars. When you click in a new line, when you type empty cars, even before you finish writing the word is popping out, empty cars. So you can execute that command and see. What you will see is just these entries. So this dataset is a dataset for cars. We have the model, or rather the company. We have the Mazda model, these things here. These are types of cars. We have Mercedes, Toyota, Suzuki, Cadillac, Fiat, those things. Then we have attribute of those datasets. We have attribute of those datasets. We have MPG. We have the number of cylinders. We have the displacement, HP power, all these things here. The number of gears, these things there. Now, what happens when you want to display? When you want to display only displacement from this entry, you just return empty. Then you use that $, then you can return any entry, any column that you want to return in that particular data set. So okay, let's return. So in your code, we can access the HP column. HP column is where? Is this one, I think. Yes, this is the HP column. Using what? Using this operator. So when I execute this command here, what I have is validate null. Yes. I wanted to return the HP, not the value dot. I want you to click on HP under this. We have HP here. Then you can run the command. So you have all entries of HP. If you want to return other columns, you can just type their names here. So yes, that is it. So method 4, subsetting using subsetting in R using the subset function. We have another inbuilt dataset called the air quality or air something, air quality. So the subset function in R programming is used to create a subset of vectors, matrices, or data frames based on the conditions provided in the parameters. For example, when you call the air quality data, let's see, the air quality data here, this is an inbuilt dataset that comes with this particular language. So we have the ozone, we have the solar, we have the wind, we have the temperature, month, and day. That is air quality. You can subset. You can apply subset function to subset air quality where temperatures are less than 65. For example, we were returning in SQL data with the point, for example, less than 1000. Now what are we doing here? We are doing the same. Now we are doing a function called subset, which we can use to subset the temperatures here, which are less than 65. What happens when I run the command? Yes, the RQ, then and display the values of RQ. You will note that what we have is values with temperature less than 65. With the temperatures, let's see. Let me expand this one. From this part, let's execute the second command. Yes, this is it. So these values of temperature that is less than 65. From empty cars, you can return empty cars with gear which is equals to 5. You can return with multiple conditions. We can return the HPs which are greater than 200, for example, and select what are we selecting from this output of subsetting this whole data. We are selecting only gas and HP. We are selecting only gas and HP. Then I can return my entry. Yes, we have gas and HP. What happens if I delete this one here? What will happen? I will return all the data, all the data, but I wanted just to return those two. From there, I think we can call it. And today we have we entered a little bit more commands, so you can go through them at your own time, and you'll be in good position of understanding this language. Do you have any question before we end this meeting? Any question? Do you have any question, guys?